Welcome everybody. Thank you for joining me today, and I hope everyone out there is doing well. I'm super excited to be here talking to you about composability and databases. What I'm going to be doing in this talk is sort of giving just a general overview of what composability is and how it relates to building your application. Then we're going to talk about how it relates to databases and how you might use an ORM to help push along this idea of composability within your system. But before we get into any of that, I'll just give a quick overview of who I am. My name is Sabin Adams. I'm a developer advocate at Prisma, and I live in California. And then I added my Twitter handle here. Feel free to reach out to me at any time if you have any questions about this talk, if you're watching it after the fact maybe, and you have any questions for me or just want to reach out, please do. I love to get messages, and I'll try to answer it as soon as possible. But let's go ahead and jump right in, and I'm just going to give a quick little overview of what composability is. At its very core, composability is a system design pattern. It's a way of building your application where pieces of your application aren't so closely tied to each other that they can't be switched out with other technologies. So for example, if you have, say, a microservice architecture and you have different services running in different ways, maybe even different languages on your different functions, on your different microservices, that would be a composable architecture because you could take out any one of those individual pieces and replace it with something else that's compatible, and it should just continue working. Your other microservices don't really care what that one's using or what it's made of. It just cares that it gets the same input and output. So that's the idea of composability as a pattern. It's just not tightly coupling all of your pieces together. What this really is a way of thinking. So as you're developing your applications, if you are taking composability into account and sort of building in a composable way, you should be constantly thinking how the different pieces of your applications relate, how they talk to each other. Do they talk to each other in a way where only these two technologies could work together? Or is it built in a way where you could easily just pull one of those pieces out, swap it in with something different, and continue going like nothing's changed? And so that's the idea here, is that you want to sort of achieve that to have a composable architecture. And the reason you want to even worry about any of this stuff is future-proofing. And what I mean by future-proofing is basically accounting for changes that might take place in the future. For example, as your business grows, as needs change within your application, maybe you pivot the application even, and it starts doing something that you never imagined it would do, you should be able to swap out your technologies to account for those changes without having to undermine the rest of your system. So that's the whole idea of composability, is just making sure that your system is ready to change when it needs to, and that it can be up and running in a pretty efficient way and a pretty safe way, where if an individual service goes down, maybe an individual piece of your application goes down, not necessarily the whole thing will. And so keeping this in mind, how does this relate to databases? We think of a database as just a constant store that can be up and running, and it can be, it should be always up and running. It should always have your data. We don't really think of it spinning up and spinning down, unless you're thinking in the world of serverless databases, but even that's a little bit different. It doesn't quite work that way. So how do databases apply to this whole world of composability? Or do they even apply to this world of composability? And the answer here is yes, and I'm going to go over a couple of points of why we should even worry about composability within our databases. And the very first one, I kind of touched on it a second ago, is business needs that sort of grow and change. So as your business develops, maybe your application gets bigger, maybe it changes, maybe the business itself changes and you have more money to spend on maybe costlier technologies that make more sense. You should be able to pull out your database and switch it with something that makes more sense for your business. And now I say this lightly, but it is still a daunting task. It's still a really big task. And I think no matter what, pulling out your database and switching it with something else is going to be a pretty crazy task, because you're going to have to get your data moved over. You're going to have to account for all those different changes. But there are some tricks that help make that a little bit easier. And I'll talk about those a little bit more as we get further into the talk. But yeah, the next piece here is flexibility. And again, I sort of alluded to this before, but the whole idea of composability is being flexible. You should have freedom to use the technologies you want to switch which technologies you're using if you're not quite happy with something. And the same goes for your database. If you aren't happy with your database, if you aren't quite getting the performance you need or specific features you need and something else can provide that, you should have the flexibility to move and not be locked in. Another thing, though, that composability opens up on more of an administration side is it opens up discussion for using these better technologies. So if your system is built in a way where your database is locked in, you can't really switch because everything's sort of hard-coded to work with this specific database. It's a hard pitch to get your company, maybe your manager or the technology lead, whoever's managing that. It's a hard pitch to get them to agree to switch databases or to even listen to the request for it because, like I said, that's such a big task. It's so hard to be able to pitch this sort of thing. But if your application is built in a composable way where that task is maybe a bit easier, you can incrementally make those changes, or you can just sort of work on those in a siloed sort of environment and then apply it once it's all ready to go. It opens up that discussion, makes it a lot easier to pitch to whoever's managing those decisions and actually making those decisions. The next thing is preparation. So when you have composability in mind, specifically when you're thinking about building your database, the previous things that we've talked about have been more about existing applications and how they grow and change. But there's another aspect to this is if you're just starting from fresh, if you're starting a new application, you want to set yourself up for success. So you should prepare beforehand. So the idea here is to lower your technical debt. So if you build your application in a way where everything is composable, that makes for much less technical debt. It sets you up for success in the future. And then lastly is modernization. Composability is the way that we see a lot of different technologies going. The whole programming and development ecosystem is moving in a more modular way with composability at its core. And so I think that's a good reason to make sure that we're applying this sort of idea to everything that we do, including databases. Because if things are moving that way, we want to keep up with modern times, we want to keep up with modern technologies, and so that is sort of just the way to go right now. But with all these things in mind, we got to ask ourselves, but how do we actually do this? Sure, theoretically, this is a good idea, this is what we should be doing, but it is a really, really tough task, and how do we actually do that? How do we take care of that in our application? And there's a lot of different ways. There's a lot of different things that you can do to build your application in a composable way to make sure your database is part of that composability idea. But I think one of the ones that gives you the most bang for its buck is using an ORM. And I'll talk about that a little bit more specifically, why I feel that way. But let's take a look at how ORMs actually fit into the world of composability. The very first thing is that in general, an ORM will sort of sit in your application. It's part of your application code, and it reaches out to your database. And the idea here is that your application uses this ORM to communicate with any database. So maybe you're using SQLite, MongoDB, Postgres, MySQL. It doesn't really matter. Depending on the ORM you're using, it will likely support multiple different databases. And this is important because it gives you one single unified way to run your queries. So like you can see here over on the left, you have a SQL query that's just grabbing some information from a user. And then you have the same query on the right in MongoDB. Those look completely different. So if you think about actually switching your database, maybe you were switching to MongoDB from SQL, you'd have to go through all of your code, change all your queries if they were written manually. If you were writing raw queries, you'd have to go and change all of those just to change your database. And that's a huge task depending on the size of your application. However, if you're using an ORM, you would have a single unified way to run these queries so that it doesn't matter what the underlying database is, the code should look exactly the same. And so that's the biggest benefit of using an ORM in terms of composability. But that doesn't apply to all ORMs. What I think a good ORM should have is a good migration tool, a good data seeding tool, easy data modeling. And I didn't add it on the slide here, but this one's more of a given. Your ORM should be able to support different databases. That way you have that sort of composability available to you, where you could switch out those databases. And that's where Prisma comes in. So I do work for Prisma. We have an ORM, and we have a couple other different products that are built specifically with modernization in mind. So a lot of these are going to help you move toward a composable architecture. But I'm just going to talk about a couple of the key features here and how they might help you. The very first one is our schema language. So this goes along with the sort of data modeling point that I made and what a good ORM should have. And our version of that here is the schema language. And what our schema language does is this is where you sort of define the different tables or maybe collections if you're using a NoSQL store in your database. And you define how to connect to your database and different aspects of your data and its shape. And what this does is gives you a single unified way to actually define that data shape and the different tables and collections in your database. And it's non-specific to the database provider that you're using. The next piece is the client, which is what you would expect and what you're probably familiar with working with an ORM. This is just the way that you actually write your queries. So as you can see here, you have different functions that will run queries for you without you having to write the raw query. What this does is abstracts that querying down to a higher level, or I guess up to a higher level, so that rather than writing those raw queries, you're writing this in a single unified way. The next main feature that I think helps with this idea of composability is migrations. And Prisma does support migrations. It has a nice little migration tooling system that allows you really good flexibility on running these migrations and safeguards against running them. And the reason I believe this helps a lot is because as you're moving towards a new database, as you're switching out databases maybe, you can look back at your migration history, see what's changed. You can also once you get to your new database and start changing things to be specific to that database provider, you'll be able to run those migrations safely and have an idea of what's been changing. And then finally, there's the data platform. This is something new that Prisma has recently released into general availability. And what this does is it gives you a set of tools that allow you to use your data in a centralized place. It allows you to manage your database and your querying in a centralized place. And it has a bunch of different cool features. And one of them that I'm wanting to mention specifically here is connection pooling. And what this does is it sort of puts up a proxy between your code and your database. And it allows you to use this in sort of a serverless environment. So it will help you avoid the connection pooling issue that you see when using databases in a serverless environment. If you're not familiar with that, when you have serverless functions, maybe you get a traffic spike and it spins up a bunch of different functions. Each one of those functions is going to need to make a connection to your database, and eventually it might exhaust it depending on how big the traffic spike is. And so connection pooling, what that does is puts up sort of a proxy between your code and your database to actually queue up those connections there and allow you to continue using your database without exhausting those connections. So that's one nice feature about the Prisma data platform. And the reason I wanted to mention that one specifically is that this whole platform allows you to apply a connection string to a database, and then you're using that database. Once you've given it the connection string to your database, it'll know how to connect to that database, how to run queries to that database and sort of put up that proxy between it. And it's just a matter of switching it in the UI. And there are specific databases that we support, so you can go in there and see those. But this allows you that flexibility of setting up that database in a centralized area. That way you can switch it out whenever you need to. So that's all great, and those are all different little pieces of Prisma and some of the main features. There are other main features that we develop on very actively and work on a lot, but I think the ones mentioned here are the ones that specifically apply to composability. But how can Prisma help you with composability? Why is this even, what would this look like in an actual application? And I think a little bit better than showing some slides is actually jumping into some code and showing you what the process would look like moving from one database to another. So I'm going to go ahead and do that. I'm going to switch over to a code window. So I've popped open this project, and what this contains is just a simple Express application and I've set up Prisma within it to connect to a SQLite database, and then I've modeled out some data here, and we'll look at that more deeply in just a second. But first of all, let's look at the application itself. So it is just a basic application. It's all just one file. I've set up Express. I've instantiated an instance of the Express application, and then it's just listening on a port. The only other things that I've done here is I've imported the generated Prisma client, and then I've set up a couple of routes to just grab some data. So we've got one to grab a list of all the users in our database. We've got one to grab just a single user in our database. And then we've also got this one here to grab all the individual posts that a user has posted, who in the database that post might mention, and any reactions to that post, sort of like a simple social media type thing. So that's the application code for it. It really is quite simple. If you're curious how the Prisma ORM actually works, definitely check out our docs. We have really great docs on all of this. And they should walk you through how all these individual pieces work. But the important thing to note here is that these are running queries for our data, and they're not using the raw query language of the underlying database, which in our case right now is SQLite. The next important piece is this schema.prisma file over here. And over here, like I had mentioned previously, is where we model out the data for our database. So we can see here we're connecting to a SQLite database. The URL for that is within this database URL environment variable. And then we've got a couple of models here. And what these end up being is a table. So this will be a user table within our database. It's going to have all of these columns. And I've set up some relations here. So there will be like a one-to-one relation to a profile. A user might have many posts. They might have reacted to many different posts. They might have mentioned multiple people in their posts, and they might have been mentioned by multiple people in their posts. So there's quite a bit of stuff going on here, a little bit of complexity in this database. And then, of course, we've just got the other models, and these are all just going to be the table name with the different columns within that database table. And keep in mind here that this is very much a sort of relational setup right now. This is built on a relational database. This is for SQLite. So this should be pretty familiar if you're familiar with relational databases. And so what we're going to do here is we're actually going to switch the database. We're going to switch to use MongoDB, and we're going to see how Prisma sort of helps aid us in that switch. The very first step here is just going to be switching this provider to MongoDB. And already we can start to see the power of how Prisma helps you transition to a new database and helps push you towards this idea of composability where you can safely switch things pretty easily. So all we've done is switched this one key here from SQLite to MongoDB, and we can see that we got a couple of red squiggly lines. That means there's errors. While that might seem bad at first, this is actually a good thing in our case. So now we know that if we are going to use MongoDB as our database, these are the problems that we're going to have. So it's looking like right here, this sort of ID does not work in MongoDB because Mongo does have its underscore ID column that it generates, and we want to make use of that. So we're going to have to go through and change all of our ID columns to use that underscore ID. And there's a specific way to do that, and we'll go through that in just a second. But the next problem it found is that MongoDB doesn't support compound IDs. So what I have here is two different columns in this database table, and I was using those previously as a primary key, sort of a compound key. MongoDB doesn't really like to do that. So it's letting us know, hey, if you do switch to MongoDB, you're going to need to make these changes first. You're going to need to regenerate Prisma client, and then you should be good to go. So actually, if we do that, I'll just go ahead and copy all of these. So anything that has this sort of setup here should be the same thing. So we'll do a new ID. It's going to be a string. We'll let Prisma know that this is the primary key. And then we're going to need to set a default value. And what this default value is going to be is auto. This is going to let us use the underlying database's method for generating these IDs. And then finally, we need to map this column to the underscore ID. And what that's going to do is it's going to let us use this ID key within our code when we are accessing the ID of a user. But when it actually stores the data and when it retrieves the data, it's going to know that in the database, this is actually called _ID. And then finally, we need to provide the db.objectID type because that is the actual data type that MongoDB uses. So as you can see, once we've done that, it now says, hey, you're good. If you were to use this in MongoDB, this will work now. So that's great. We'll want to actually copy that over to here as well. And then we're going to want to copy that over to here as well, because all of these are going to need to use the same type of thing. So what we're seeing right there is now that we've switched these to strings, we're going to need to switch this to be a string as well. These were ints previously. And so the thing I want to note right here is that it does look like we're making a lot of changes, and we are. So the switching of your databases is still going to be a bit of a task because this is what stores what's important to your application, the data. There's a lot riding on your database, and so pulling it out and switching it with something new is always going to be a task. But what's important here is that Prisma's helping us to do this. It's helping make it a little bit easier and more apparent what needs to change before we can actually move on. And so now that we have a NoSQL store running this application, we can't use these compound indexes. So I'm just going to go ahead and get rid of this guy actually. And what we're going to do is we're just going to create an ID column on this table to use as a primary key instead. And this will just have a like a randomly generated ID. So we'll do a string here. And actually what we're going to do is we're just going to copy this. This will work just fine for our ID. This will be what MongoDB expects. And so that should work really good. So now we can see we have no more issues. And this should be good to go. So if I open my terminal, I'll run npx prisma generate. And we've generated the new client. And so now that we've done that, we could see we have an issue over here in this index.ts file. And what is that issue? The issue is that we can't actually apply a number to a string. So it's recognized that over here we have changed the data type of these ID fields. And now that that data type has changed, our application code is a little bit different. So what I'm going to do is remove these. Just anywhere we're using this number. And I think those were the only places. So at this point, we've had to make pretty minimal changes, and we've switched from SQLite to MongoDB. I don't have a MongoDB instance running, but if we were to run this code, it should run exactly the same as it did before. It should work just the same as it did. And the whole idea of composability applies to this because, as you can see, we made the switch up here. It let us know what in our database's schema actually needs to change to use that underlying database. And then once we made the changes, it told us what in our code needs to change. So because we weren't using raw queries, we didn't have to go through and change everything. And because we were using an ORM that's smart enough to know what actually works with the different database providers, it was able to tell us exactly where we needed to change our code and what we needed to change, just to save us that time on actually finding those changes and making them. So all of that together, I think, is what Prisma brings to the table as a pretty powerful set of tools for making sure your databases are composable, or at least preparing to switch your databases in case you are moving to sort of a composable architecture. And with that, I think I'll leave you guys. Thanks for watching. I really appreciate it. And like I said at the beginning of the talk, if you have any questions about how any of this works, about how Prisma might help you in a composable architecture, if you are thinking of moving to a composable architecture and you're thinking about maybe using Prisma, please do reach out to me. I'd love to answer any of your questions and maybe even talk you through some of the process that might go into it there. So thank you.
Hey, thank you so much for watching that. I really hope you got value from it. By the way, if you want more where that came from, go to composability.dev and register to be a part of our community today. And if you want to be even more part of our community, go to Twitter and look up JavaScript Jam and follow us. Every Wednesday, we go live at 12 p.m. Pacific Standard Time, and we talk about anything and everything web dev. It's an open mic for everybody, whether you're a beginner, whether you've been doing this forever. We'd love to hear from everybody, and there's always so much value and good conversation going on there. We wanted you to be a part of it too, so come join us. And by the way, if you left a comment below, that's exactly where the comments are going to be answered during the live Q&As with the speakers. JavaScript Jam live on Twitter Spaces. All right, go to JavaScript Jam. Do it now.